So, David, stage is yours.
Thank you. Hello, everyone. I'm David Gambuli. I'm a sustainable consultant for the clothes and apparel sector. And today I'm going to talk about a project in particular on which I work on, which is shoes related, a bit borderline, but we will talk about shoes as well. But first, I'll talk to you about the company I work with for this particular project, which is specialized on sorting polymers, which is something that's definitely on a topic across sectors, we can say. And they developed a special machine for that, on which they won several prizes when they were born as startup in 2010. And since they are based on a new technology, or at least new for this kind of application, which is a triboelectric effect, which, to explain it easily, it's electrostatic charge, okay? The same as you will get if you charge a balloon on your sweater and it stands. That's electrostatic charge. And this, it's pretty revolutionary on this field because it allows to sort particles of polymers which are really similar. You don't have to take care of their density, their color. Regardless of this, we can sort it. And we can sort it to a really high degrees of purity. That 99.8% is not marketing, but it's what we have done. This was really an extreme sorting for a compounder with whom we work with for a long period on PA to sort PA11 with PA11 charged with fiberglass. And on that, since they were compounding in back, they could accept just at 0.2 of impurity, and we managed to give it to them. So it can be used on any kind of form, like from the pallet, on the scraps, and we work on third-party sorting with TPU, TPU based on ether and ester. On that, we did some sorting also for the ski boots sector on that. PA11, indeed, the one I was telling you. PA12, 66, as well as PC, ABS, PS, and of course the most common and with higher volume, of course, which is PT, HDPE, and PP. So now let's go to the project. This was a project funded by you, LIFE project, actually. The target was to produce 1,000 of ski boots from old ski boots. So that was the first time that from old ski boots, included the liner, we made new shell and new liner from the old one. And we got the materials from the rentals all across the Alps. And on the plastic sort side, we were the one in charge of doing all the sorting of the material and then ending it out to the producer so they can produce it again. And we, apart from our core machine that we already had and we tuned for the project, we had to build 2 new machines that now we are using it, of course, also for other application. First, a rubber machine, because I don't know if you may know, but rubber is like a black sheep to have inside polymers in the recycling world, because of course it behaves completely different and you really don't want to have it. So first, it was necessary to get it out. And the second part are multi-material pieces, because of course here all the projects and all the line is developed to be, and it is automated. We are not talking about disassembling, okay? And so once it's shredded, you may have, of course, pieces, even if as small as few millimeters, which have 2 different materials inside. And those, they can one charge, they can be randomly go in one direction or the other. Something that, sorry, that I didn't say before is that the sorting system is binary. So it doesn't matter how many materials you have at the beginning as input, but the sorting is done in binary mode. So one direction and the other. So if you have more than 2 materials, you would need more passages. And that's also something, well, you could say is a weak point, but of course, like sorting, it's it's a complex factor. And you go and target the one that is more relevant with a higher percentage, and it's also easier afterwards to be used and recycled, of course. So this was, and getting out this piece, of course, that will decrease the purity of our output, it was a key factor. And then going to collect the 3 main material that we had as components of a ski boot and its liner. So the TPU of the shell, the outside, the EVA of the liner. That was really the trickiest part, as you will see afterwards. And then the PP, which is the inner sole at the end, under the liner, okay, which is in the, and that you could theoretically even remove it manually, but of course this was all done automatically. So these are the 2 machine developed. On the left side, you have the rubber machine, and on the right side, the multi-material machine. In a few, we will see them on action. But from the eyelet of the multi-materials, you'll see how it works, at least not ongoing, but there is the material is falling down, and then you have a camera which is observing and recognizing if it has more components, actually. So there is an air ejector which is pushing the material out, and so wasting it out of the line. So now just I'll walk you through the recycling process, how it had happened step by step. So indeed, we start from the old rental ski boots that you may see on the line. They were grinded, first steps, and then, as before was mentioned, of course, well, compared to shoes, there is a lot of metal, and some magnetic and some not. And so 2 different kind of sorting, which means getting out the metal part with a ferromagnetic system, and then with eddy current, instead, you take out what is not magnetic, okay? Then we go to the polymers. So once you grind it, I don't know if you have had the chance of seeing it, once you grind an expanded material, it takes that hairy, fluffy appear, which may looks really nice, but it's terrible to handle, because particularly like we handle everything by hair, so of course having such a light density, it's always around. It creates dust, it creates problem in the sorting, and it's mostly on the top when you do the selection, but it stays also under. So it's really tricky to handle. So it's the first one to get out. And technically, simply with air vacuum system, we expire it, mostly at the beginning, where there is still the most out of it. I think mainly 80% of it we managed to sort it at the beginning. Then the remaining, it's actually we aspirate in throughout all the passages. So there is always a few left, and then we take it out all the time. But most of it is done at the beginning. And then there is the rubber, as we were saying before, which is a critical contaminant, and is the first one to be take off, so inside the rubber machine. Then the multi-material one, and finally we go down, once the multi-material is sorted, to the 2 main polymers that we were targeting, TPU and PP. And this comes in a mixed form. So I know that the colors are misleading, but this process was long one. So also to get the shooting from the production, it was tricky. But believe me, those are coming from the same sorting system, just different batch of colors of ski boots. And then so we do the sorting with the core machine between the PP and the TPU, okay? And now I'll show you the running video. Oops. So once the material is shredded, that's the intake that you have from the big bag. Okay, and first part, as we were saying, is the dusting. So all the EVA is sorted, most of it, and we collect it here, as you see. So it's really low density, but with it you may see some material also, because with this mechanical structure, of course, it traps some material. So that's unfortunately, because you won't be able of getting that material out of it, but it's a minor loss along the process. Then we'll see. After we take it out, so the material is much more cleaner. There is no more the components. Then we see the two machines, and here running the multi-material. Well, it's pretty fast, the switch, but this one is the one you were seeing before with the falling material, you see, and the detection. And here you see the output of the multi-material. So the polymers clean with from the multi-material is just TPU and PP. And the multi-materials, you see, you still have like the expanded material as well as, indeed, mix situation. And, well, and then it's sorting inside. And here we have the two outputs, which is TPU on one side and PP on the other. Exactly. So, well, this is how it's coming out. And those were the results of the project. So we have two numbers to check. The objective of the project was to have materials pure up to 95%, that we did manage, particularly for the two most needed, the TPU and the PP. With the EVA, we were pretty close, 93 on average, but something that is more relevant, I would say, for the industrial production, because this is like a line. It wasn't like a prototype. Like those machines are running. It's something that can be done. We have an efficiency with just the project. So with bigger numbers, we can, of course, increase our efficiency line. But it was 75% for the TPU and the PP, and a bit lower, 70% for the expanded, for the EVA. And I mean, it's pretty satisfying on our side for a project like this. And if with the practice, this could be definitely lower. That's what is interesting. And with volume, it can definitely be something of value. And this is something here I want to bring you. Another example that we did had the chance of testing. It was actually for another project that at the end it changed idea, but we did do the trial for that, and it was indeed on a shoes, where the shoes had been first processed by another company which was melting the leather. They were putting in a bath, a specific one, which is covered and patented. And then we received what was left of the shoes, and they ask us to do the test of sorting between mainly the EVA and the rubber, of course. I mean, the upper part, the textile composing the upper part of the shoes, of course, was considered at waste, because while the other two materials, they can be more easily reintroduced into the production line, with the textile, up to now, with the mechanical, we go down on downgrading, unfortunately. It's not easy to use it as such, even if there are some possible application. And for example, the EVA of the liner of the ski boots has been used. It has been practically like compressed and glued to create another liner. With the textile, most probably like a chemical application would be the best solution to go on it. And I know there are several solutions now running and some plants on construction which are working on that. But still, the mechanical solution for some kind of sorting, especially if it's already in place and running and not just a prototype, it's something that can be really effective. And for that, we did some testing also like on helmets, both on motorbikes and bikes, as well as sunglasses, because doing all the sort on the harder plastic, for us it's easier, let's say, so compared to a textile. And on those we work pretty well, like the ABS or polycarbonate of a cask can be easily sorted from all other elements or small particles. And as well the acetalato of the skeleton of the sunglasses with the polycarbonate of the lens. So these are all possibilities that can be tackled, and yeah, that's it. Thank you.